Good afternoon, everybody. I've gotten a couple of requests to go over some of the questions on homework 2B, that two-page packet. And the questions I was asked for was started with number 18, draw the velocity time graph for this position time graph. So, if we've got position time graph already, the way we get the velocities is by doing slopes. Because a slope on this type of graph, let me just draw one here. Let's say I want the slope of this line. I'll just pick this one. My rise is how much my position is changing. And my run is how much time is changing. So this is my delta x, essentially, over my delta t. And that's what velocity is. Change in position over change in time. So I just need to find the slope of each line segment, and then I'm good. So, first one, we're going 5 meters in 5 seconds. So, 1 meter per second. So I'm just going to kind of make a table here just so I remember. So from 0 to 5 seconds, we're doing 1 meter per second. I don't want to draw the graph yet because I need to see how big the numbers are going to get and so forth. Now, from 5 to 10, think about what's happening here. From 5 to 10 seconds, the position was 5, and now it's still 5. They have not moved at all. Well, that makes that easy. From 5 seconds to 10 seconds, my velocity is 0. And look at the slope of that line. The slope is 0. A horizontal line on a position time graph means you're not moving. All right, on this one, looks like we're going up 10 and over 5. Up 10 over 5, that's going to be a slope of 2. So from 10 to 15 seconds, my velocity is a positive 2 meters per second. Now I've got another horizontal line. We're at 15 meters away from the origin, wherever that was. And now we're still 15 meters away. Again, you're not moving. So from 15 to 20, it's 0 again. And now from 20 to 30, notice my line is sloping down. We've got a negative slope, which means we're going to have a negative velocity. And we can calculate the rise over run for this. Just go from here to here. So we went down 15. And we did that over 10 seconds. So negative 15 meters over 10 seconds. I'm going to get negative 1.5 meters per second from 20 to 30. All right, I'm ready to graph these numbers now. And I need some positive velocities and I need negatives, so I'll just draw my axis somewhere in the middle here. Sorry. And so 0. And we got to go up to positive 2. So I'll just count by. That'll be 1 meter per second. Here will be 2 meters per second. Negative 1, negative 2. You could have stretched the scale out a little bit, and it would have worked just fine. So, from 0 to 5 seconds, the whole time you're going 1 meter per second. From 5 to 10, our velocity was 0. So just jump down. And I should probably pick a marker to do this so it'll show up a little better. And we just keep moving along, 10 to 15. Now we're up at positive 2. From here, from 10 seconds to 15 seconds. This might work a little better. be a lot thicker anyway. Now I'm up at 2. And then we drop down to 0 again for the next 5 seconds. And then for the last 10 seconds, we're at negative 1.5. Trying to make sure I get it on the right line there. All the way to the end. If you want, you can draw a little dotted line just connecting them. I wouldn't mark you down if you didn't have those, but some people feel better when those are in there. All right. Hopefully that helps on that one. And let's go look at... Sorry, my graph is bleeding through. Ignore that down there. The questions asked here were 23 to 27. And make sure you notice that this is a velocity. It should say it, but it doesn't. In meters per second, velocity versus time graph. So, all these questions are asking about displacement. And displacement. 2 ways we can get this. One is, we've mentioned it a couple of times, the area under the curve. So when they say interval A, they just mean find this area. That's it. And we'll look at that calculation in a minute. When they say interval B, they mean this area and just that area. You're not being asked the displacement from 0 to 10, although they could have, and then you'd have to add those two together. They just said from during interval B, so they mean just that part there. So, area under the curve is one way to get it. The other way to get it is, remember our formula is average velocity is change in position, or displacement, over the change in time. I can rewrite this, and I often will, this way. That this displacement is the average velocity times the time, or the change in time. Or the other letter we use for displacement, remember, is D. So we can use this to get displacement. The only catch is you have to use average velocities when you're doing that. When the velocity is changing, I can't say, oh, I'm going to use 5. I'd have to say I'm going to use the average velocity over that segment. So we'll do some by area. We'll do some by doing divot here and see that you get the same answer. So interval A. Let's go after that one with the area. It's a triangle. So for A, it's going to be 1/2 my base. We'll call that the base, and that's 5 seconds, times a height of 5 meters per second. And look what happens with the units in that case. The seconds cancel out, and I get just an answer in meters. And what have I got? 25, half of that, so it's going to be 12.5 meters. When I get to interval B, it's a trapezoid. I could do the trapezoid formula. Here's my base 1 and my base 2. So I'll work that up here just where I've got more room. So my base 1 we'll call that 15, plus base 2, which is, how tall? 5 there. Because I'm after what is this here, and this is 15, and this one's 5, over 2. Area of a trapezoid is B1 plus B2, over 2, divided by the height. Or, multiplied by the height between the bases. Base 1 plus base 2 over 2. Or the other way of saying it, average those two bases, that one, and then multiply by the height. So I've got the 15, I've got the 5, and divided by 2. And now I just need to multiply by the height, which is my time here of 5 seconds. So we're going to get 20 divided by 2 is 10 times 5. And this was in meters per second, remember? So again, my seconds will end up canceling, and I'll get an answer just in meters. What do we say? An answer of 50 meters. If you don't like the trapezoid, you're more than welcome to break it up into a rectangle and a triangle. My rectangle here would be 5 times 5, which is going to give me 25. My triangle, my base is 5. Let me write that darker here. My base is 5, and my height here for my triangle is 15 minus 5, so that's 10. 1/2 base times height, 1/2 of 50 is another 25. I've got 25 and 25, I got 50. Now, I said we could also use divot to get there, and in many ways it's a lot quicker once you get used to that. Segment B, you started at 5 meters per second. You finished at 15 meters per second. In divot, we need the average velocity. The average of 5 and 15, well, how do I average two numbers? Add them and divide by 2. So I'm going to have 5 plus 15, divided by 2. Average those two velocities, and then multiply by the time that took place over, that's 5 seconds. And anybody notice this is the same thing here? That's because that's how we got this idea, by finding areas we're getting displacements. This average velocity is really the average of the bases of that trapezoid, and then times the time, which is the height of the trapezoid, so it's going to have to come out to the same answer, and essentially the same work here. So, you can do it by a trapezoid area, a triangle and a rectangle area, or you could just do the average velocity times the time. You just got to remember, you can't use 15 or you can't use 5. You've got to use the average of those, which, yeah, is going to be halfway in between them. Halfway between 15 and 5 is 10. That's the average velocity. C is probably the easiest one in the mix there, because it's just a rectangle, so I would just do that. Or divot, because your average velocity is 15 times 5 seconds. Bam, you're done. D is going to be another big trapezoid, and so is E. So take your pick. What do you like best? Now, let's see. What have we got? If I do the trapezoid, I'd have 15 and 10 for my bases, because this is 15 and this is 10. So I'd have 15 plus 10 divided by 2, and that's in meters per second, times 10 seconds. So 25 divided by 2 would get you 12.5 times 10, 125 meters. If we did divot using the average velocity, I'd say, average out 15 meters per second and 10 meters per second. Average those two numbers, you get 12.5 times the time frame here is 10 seconds. So 12.5 times 10. Bingo, same answer. Last one's also a trapezoid. I'm going to just do divot again the last time here for E. I'm going to pick, well, my velocity there is 10. My velocity here is 5. So 10 plus 5 divided by 2, average your two velocities, times the time, which is 5 seconds here. And what do we end up with? 7.5 times 5, whatever that comes out to. And you're good. All right. And that wraps this one up. Let me know if you got others, and I'll make a video.